Hi everyone, so in this video we are going to learn about the math library in Java. So math library is basically a class which has a lot of built-in methods related to mathematics, and it is really helpful and useful and comes really handy when doing mathematical stuff. So I'll just quickly show you. We are going to cover these functions, but that doesn't really mean that there are only these functions. There are total 138 math library methods over there, but of course like you can check it out on your own whenever that is needed, but these are the most important ones that we'll be looking into. So first of all, how to import math library. So the first thing you got to learn is how to import it. So whenever you're using Java, you just got to write import java dot lang dot math. This is the class. So this is a package. This is another package within this package. So there is another package within this package, and inside this package there is the math class. This is the math class. Okay, this is the math class, and within this math class you have a lot of methods. These are the methods: powers, square root, cube root. All these methods you have inside the math class. So let's see on using math class. Okay, let me clear it. Yep. So let's import math class first of all. So again, the way to import it is import java dot lang dot math. That's how you import it. Once you are done, then you can directly use the method. So the first method that we are going to look is the pow method, and remember, all of them are static methods. Okay, all of them are static methods. And how do you call static methods? You write the class name first, dot, then the method name, and then you pass the arguments, right? That's how you call static methods. So all of them are static methods. Okay, you don't have to create objects of math class and then do your stuff. So you can directly call math dot pow. And before jumping into it, let me show you how many functions does math class has. So math dot, as you can see, there are total more than 103 methods over here. See, all of these are math functions. So of course we're not going to see all of them because it would take a lot of time to cover every single of them in detail. But yeah, we will be going over the most important ones, and then you can try on your own whenever you need it because it's available on the internet, right? So let's get back, and the first method that we're going to look is pow. What is pow? Pow is power, nothing else. Let me clear it out. Pow is power. So math dot pow, and it's basically, let's say, 3 to the power of 2. What is 3 to the power of 2? 3 3 is a 9. It would give you 9. And by the way, all of these are coming in double. Okay, these are double, not integers. Okay, yeah, of course, if you want integers only, then you can typecast it and you will get 9. That's absolutely fine. But anyway, the default result is always going to be in double. So yeah, there you go. This is pow. There's nothing much to complicate it. Let's see, math dot pow 4 comma 3. So what's going to be the result? 4 into 4 into 4, 64. Okay, so that's how this method works. And of course you can combine things here as well. So let's do it. Math dot pow, and now I'm going to say math dot pow 2 comma 2 comma 3. What is this? Let's see. This is 64. How are we getting 64? Let me paste it over here. Let's paste this. Okay. Now let's understand this. So basically what is happening here is math.pow, and always start from the inner one. Okay, what is the inner one? This one and this one, no? So start from this one first. Math.pow 2 comma 2, that means 2 to the power of 2. Okay, so this is done. This is basically 2 to the power of 2. Okay, cool. And then you are saying, then slowly come outside and check the exterior one. Math.pow 2 to the power of 2 to the power of 3. What is this now? 2 to the power of 2 is basically 4, and to the power of 3, and that's how you get 4 into 4 into 4, which gives you 64. Okay, perfect. So that's how power works basically. So nothing more to complicate it. You can of course make it, you can combine more things. You can say something like this, although this would give you a big result, but let's try this one. What about this? Math.pow 2 comma 2 2 comma 2 math.pow 3 comma 3. Now what is this? This is a very huge number. Why is it so? Because uh, let's see this. So copy this up. Let's go back over here, clean this out, paste this. Let's take a look over here. All right, let's see what's happening. So start with the inner ones first, this one and this one. So what does this say? 2 to the power of 2. 2 to the power of 2. Okay, fine. 3 to the power of 3. Okay, cool. So this is basically 2 to the power of 2 is 4. 3 to the power of 3 is 9. 27. 27. Yeah. So now come to the outer one. What is this saying? This is saying 4 to the power of 27. This is basically saying 4 to the power of 27. Now this is a very big number, very big number. That's why you are getting a E when you are trying to see the number. If you come back once again, you will find a E in this number. E basically means this is towards positive infinity. I mean, this is a very huge number. Okay. So yeah, that's what it means. So that's how you can combine multiple things at once. Let's start with the next function, which is square root. Again, pretty easy one. Let's check it out. Square root, SQRT. It takes any number and find the square root of it. Like for example 4. This basically means square root of 4, which is of course 2. Easy. It's easy, right? Let's try it out. Math.sqrt. Square root of 4 is of course 2. I mean, we all know it. What about 6? 2.44 something. What about 16? It is going to be 4, right? Yeah. So we know here. And we can combine the previous functions as well. We can do something like math.pow math.sqrt say 16 comma 2. This is going to be 16. This is still going to be 16. Why? Because math dot square root of 16. Square root of 16 is 4, and 4 to the power of 2 is of course 4 4s are 16. So you are getting 16 over here. So you can combine things. The square root is very basic method. You can just find out the square root of a number. That's it. Similarly, you have cube root. You have, what is the next one? Cube root. similar to square root, it is CBRT. Say 9. Cube root of 9 basically means, cube root of 9 means 3. 3 3s and 3. No, actually it should be. Oh, I'm sorry. Lol. Let's make it 27. Yeah, now it would work, right? So this essentially means cube root of 27 is basically 3. Let's go back and let's check it out. So CBRT will find the cube root of something. So I would just say math dot CBRT and 27, it would give us 3. It exactly works like square root. It just finds the cube root, right? So square root and cube root, easy methods. Okay, the next one. Okay, by the way, this video is going to be kind of short because it's easy. Okay, now these three, round, seal and floor. Now this is where a particular thing starts over here. So let's check it out. All right, so what is round, seal and floor? Let's say, so say this is a number line. This is a number line, okay, and okay, all this number line over here. So, and let's mark it out. Let's say this is -1, or let's do it, this is -2, -1, 0, 1, 2, 3, 4, 5, and dot 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 dot, whatever. Okay, and dot dot over here. It continues. Okay, now let's say I have a number. Say I have a number called 2.3. Say x. It is a x. It is a variable x. Variable x has a, say, number 2.3. Okay, so it falls somewhere around 2.1, 2.2, 2.3. Somewhere over here it falls. Okay. Now, three things. If you say math dot seal and you put in x, what you will get? You will get the next integer. What is the next integer? Seal means the upper value. Upper value is what? 3. Okay. In fact, I should do it like this rather. Then you would get a sense. I should draw the line like this. Now you would understand better. I do it like this. This is our number line, and these are the markings on it. Okay, say for example this is 5. Oops, say this is 5, 4, 3, 2, 1, 0, -1, -2, -3, -4, and so on. Okay, and so on over here. Say for example you have a number. Let's say number is x. X falls somewhere 2.3, or yeah, x is equals to 2.3. 2.3 falls somewhere over 2.1, 2.2, 2.3 over here. Falls somewhere over. Now you have three methods. Say for example if you say math dot seal. Seal means the upper value, like the ceiling of your wall, like a ceiling of your room. The ceiling of your room. Now if you say math dot seal x, it would give you the upper integer. I mean the next integer. What is the next integer? 3. You would get 3. If you say math dot floor, if you say math dot floor, what would you get? Floor means the previous integer. The previous integer. I mean the floor of your room. This is the ceiling of your room, and this is the floor of your room. Floor means the like the lower value, lower integer. What is the previous integer? 2. Would got 2. And there is another method called math dot round. What does math.round do? Math.round sees math.round, the logic is if x is more than 0.5, more than or equal to 0.5, it basically does the job of math.ceil, and if x less than 0.5, it does the job of math.floor. Okay, in this case we are working with 2.3, which is, we are working with what, 2.3, right, which is this case. It is less than 0.5, right? 2.3, not 2.5, it is 2.3. So we are going to do math.floor. So we are going to get 2. Understand? Okay. These are the 3 functions. Okay. So say for example we have, again let's clean it out for the moment. Say for example we have a number, call it 4.5. 4.5. What about ceil? If I ceil 4.5, what would I get? The next value, the next integer will get 5. If I floor it, what would I get? The previous integer, that is 4. I mean the lower integer will get 4. If I round it, now round has condition. Is it equal to or more than 0.5? It will first check. If x is equal to or more than 0.5, is it equal to? Yes, it is. It is, as we can see, it is 0.5. Okay, like after the decimal I'm talking about. After the decimal, if it is 0.5 or more than it, then it will do what? It will basically do ceil, and therefore it will give you the next integer, which is 5. Okay, perfect. Let's look at some of the examples quickly, just to clear any confusion if we have any. So quickly say double x is equals to 4.3. Okay, we have 4.3. Let's try to do it. Math.ceil x, we are going to get 5, the next integer. Of course we are going to get a value in format of double, because that's how math class works, but yeah, the next integer we are going to get, right? What about math.floor? The previous integer, that means we are going to get 4. Perfect. What about math.round? It first checks, is it more than or equal to 0.5? It is not, it is 0.3. So it is going to give us the previous value, that is the floor value. So yeah, like we get. Yeah, by the way, when you do round, you are not going to get the value in double format. You are going to get it in integer format directly. Okay, round gives you directly in integer format. It is basically rounding off. Okay, let's try for something else. Let's say this is 4. Let's do negative 1. Let's do minus 3.7. Okay, let's try to do the same thing. Math.ceil. What are we going to get? We're going to get 3.0. What about floor? -4. And what about round? -4. So just for you, so that you don't get confused, let's get back on the number line and see what is happening. So what was our number, by the way? Our number was 3.7, right? So it was, and yeah, it was in the negative side. So 3.1, 3.2, 3.3, 3.4, it was somewhere around this. Okay, 3.7. Okay, -3.7. So when you ceil it, Let me remove again all of these things. Yeah. So when you are basically sealing it, sealing means the upper value, the next big integer, the bigger integer. Is it 4 or is it 3? Of course, floor means the floor of your room. Sorry, floor means floor of your room. Ceiling means ceiling of your room, right? So it is the upper value. So you are going to get -3. If I am talking about floor, floor means the floor of your room. So the lower value, you are going to get -4. And when you talk about rounding, it will check if x is more than 0.5. Is it? Yes, absolutely it is. It is -3.7. So technically it should give you this thing, seal, right? Technically it should give you seal because this is more than 0.5. But since this is in negative, it would not give you seal. It will work in opposite way. It will give you floor. It would give you floor, and thus it will give you -4, not -3. Okay, that is the thing. So if it is in negative, it will work in the opposite way. Okay, try it out on your own. You will get more clarity if you are just having any confusion. Again, let's check it out once more. So seal, I'll get -3 because this is a bigger integer. Floor, I'll get the lower value, which is -4, and round would give me -4 because since this is negative, the round would work in a reverse way. Okay, this was round down to floor. Although this is more than 0.5, it would work in a reverse order. So round will not give seal anymore. It will rather give floor if it is more than 0.5. So yeah, that is what's happening. And yeah, we're done with this. Let's go back. We're done. What about floor div? Floor div, right? Yeah, we have floor div. So floor div basically means if I say, for example, 4/2, 4, 2, this basically will give you 2. It will always give you integer value. Okay, say for example 3, say for example 10, 3, it would give you 3. Why so? Because technically if you divide 10 by 3 and you want it in a double format, of course you are going to get 3.33333 something. But in floor division, what is happening is this value is getting floored. So basically this is what is happening. Math dot floor double 10, 3. This is what you are getting. Okay, so floor div basically means, if I go back, yeah, so floor div, okay, x comma y, it takes something, so it basically does this. Okay, so it divides x by y and then floors it. Okay, then floors it. Say for example, if I say 13 by 7, what is 13 by 7? 13 by 7, 1.85 and all. So now if I floor it, floor, math dot floor, what should I get? I should get 1, right? Exactly. This is a two-step process. Like, this is a two-step. You are doing first dividing it and then converting it into floor. This is a two-step process. But using math dot floor div, You're doing it in a single step. I can simply say 13 comma 7 and we are done. It will give you 1 directly. So it is basically reducing the number of lines you write, or the number of steps you do, right? This first you have to divide it and then you have to use the floor method. So it is kind of, sometimes it is a hassle. But using floor diff, you can simply divide 13 by 7 and make it floor using just a single method. Okay, I'm not dividing it manually and then converting to floor. But yeah, this is what it does basically. Nothing fancy. It just floors it out, right? 13 by 7 gives you 1.85. The floor of it is of course 1, and yeah, it does the same thing, gives you 1, like it gives you integer value. So yeah, this is floor diff for you. What about other? Okay, this is, we are done. We're done with floor diff. Let's check it out. Let's check absolute. So absolute is basically something like this. It is say for example you have -5. Okay, you have -5. If you put -5 in absolute, it will give you 5. If you put 5 in absolute, it will give you 5. So the point is that absolute removes the sign. Basically it removes the sign. It basically, say for example your age is say 15 years, right? And say for example your brother's age, your brother is say 3 years or say 5 years, for the sake of better calculation. Now if I ask what is the difference, you will either say 15 minus 5, and this is correct. This will give you 10, or 10 years of difference, right? But the moment you do something like this, say 5 minus 15, you will get -10, which is wrong, because I just want to see the gap. What is the gap between you and your brother? -10 can't be a gap. So scenarios like this, where the sign does not matter, you are going to use absolute. Say for example you are doing some calculation. For example, let's take this. So say this is some x, this is some y, and you don't know if what is the sign of x. X can be, see, x can be positive or it can be negative. Y can be positive or it can be negative, but you don't know. You don't know yet, right? You don't know yet, but you only care about the difference. So you are going to use absolute x minus y. You would always get the difference. Okay, always get the difference. Or you can also use x plus y also if you would like to, but it doesn't really care about the sign. Okay, that's what I mean. So say for example I say -30 plus 10, something like this. What would I get? I would get -20. But if I use absolute, this sign will be removed. So it just says it cares, absolute cares about the magnitude, just the magnitude, not the sign, not the direction. Okay, so let's quickly start it out. Math.abs -30 plus 10, 20, and it is always going to give you integer only. What about if you say something 3.5? It is going to give you 3.5. Why? Because this is where there is a method overloading happening. When you are giving it a float value or a double value, it is using that version of this method. when you are giving it the integer value, it is using that version of the method. So it is basically what's happening. There is a method overloading going on, what it looks like to me. So you can say math dot abs minus, or maybe 5 minus 50, we will get 45. So absolute is only for understanding the magnitude and removing whatever sign is there, negative or positive. It doesn't care about the sign. So that is absolute for you. Let's go back. What's the next method? Min and max. Okay, this is where things get a little bit more interesting. Let's come over here. Min and max. Okay, and then we'll move on to this trigonometry part, which is, I'd say, the bigger part in math library. But before that, let's try to understand min and max. So min is nothing but it is a method which finds the minimum. Say for example, what is minimum? Or let's start with max first. What is max? Max finds the bigger number between two numbers. So for example, you give 5 and 10. 5 and 10. So max would return 10. Why? Because 10 is the bigger number. Simple. Max would give you the bigger number out of 2. It accepts only 2 arguments, A and B. It will give you the bigger number. Done. And similarly, min would also take 2 numbers. Say for example, again 5 and 10. And it just works in opposite way. It will give you the minimum number, the lower number. So it will give you 5. That's it. That is min and max. But things get interesting when you try to, say for example, if you want to find what is the biggest value between x, y and z. Okay, you don't know. But the problem is max accepts only 2 values. What about this? You can do x and y. What about this? How are you going to accumulate this? So basically, say for example, all of these are user given. Okay, all of these are user given. You don't know what is going on. So you can say max. Okay, this is the outer max. Now inside this you say max x comma y comma z. That's how you find the biggest number out of all of them. How? So basically what happens is, say max will choose which one is big, x or y. Say x is big. Say x is big. Okay, good. And then once it is done, this max will find which is bigger, x or z, out of them, which is bigger. Say for example, this max will find that z is bigger. That is how you find. Say for example, again let me clean it out once quickly. Oops. Say user gives 3 values. User gives 30, 10 and 50. Okay, and you write your method like this, max 30 comma 10 comma 50. What would happen? Let's check it out. So the inner max would try to find what is the bigger number between 30 and 10. Of course it is 30. Now the outer max will try to find which is bigger between 30 and 50, which is of course 50. So eventually the ultimate result you will get is 50. 50 is the biggest number out of all of them. That is how max works. Okay, what about say for example, we have 4 values, say x, say for example a, b, x and y, and let's say a is 3, b is 100, x is 20, y is 40. How do you find? Simple. You have a max method. This is the outermost max. You have ab as a max, xy as a max. So you will write 2 maxes max a comma b. Oh, you have the values, right? So let's write 3 comma 100, and you have max x comma y 20 comma 40, right? So when you do this, this max will find which is the bigger number over here, 100. So you get 100 over here. This max will find 2040, which is the bigger number here, 40. So you get 40 over here. Now this max will try to find which is bigger, 100 or 40. So you will get 100 as the biggest number. So B is your biggest number. That's how you work with max. What about 5 numbers? What about 5 numbers? Let's say you have A, B, C, D, and E. What about these? Say you have, say for example, E is the biggest, let's say 200. Let's use a different font color. Let's say E is 200, D is 30, 100, this is 20, and this is 70. Okay, all right, let's see how would we write a method. Max, this is the outermost max. So first you combine 2 2, but now you will say, hey, what about this? I'll come to that, just see what I do. So first write the outer max, simple. A and B means 100 comma 20. Okay, happy. Now what about the C, D, and E? So here we have a trick. You can write max and you write another max over here. Within this max you write C and D, 70 comma 30, and you close this, and then you write the E, which is 200. Yeah, and then you finally close the outermost max. And let's see how this works all together. So what is the biggest of them? 100. Okay, what is the biggest of, okay, come to the innermost. Okay, this is the innermost. What is the biggest of them? 70 and 30. 70. Okay, let's use a different font color. What is the biggest of them? 70. So it will give you 70. Okay, and what about this one? 70 comma 200, which is the bigger one? 200. So it will give you 200. Fine, done. This is done. This is completely done. You get 100 and 200. Now this max would check which is bigger, 100 or 200. Of course 200. You will get 200. Okay, let's and similar thing goes for min as well. This is how you can do for min as well. Min finds the minimum number. Okay, it does the same thing, just finds the minimum number. So let's quickly go back and write it down. Mat.max, and again let's have int x or int a equals to 10, b equals to 50, c equals to 70, d equals to 100, e equals to 200. Okay, we are done. A, B, C, D, and E. Cool. Let's try to find the biggest number out of them. Max, math.max, A and B, math.max, again math.max, within this C and D, and finally E. Close this bracket as well. So as you can see, it works perfectly fine. Similarly, you can do for min as well to find the minimum number, but I'm not going to it. You can try it out on your own. Let's go back. So we are done with these as well. Now let's go to the trigonometry part, which is a little bit bigger part than all of them combined. Let me check once. This is still short, right? 40 minutes is okay. Yeah, all right. So we need to check the trigonometry table before I go into a lot. Yeah. So this is the trigonometry table. First of all, let's understand how to, how all of these things work. Okay. Say if I want to see how many degrees for this radian, I have to convert this to degrees. Okay, let's see how we can do that. So pi by 6, pi by 4, pi by 3, let's try to do that. Okay, so I have it open here. I have to say math dot to degrees, I can say, and there is, by the way, there is a constant called pi. There is a constant called pi within math class only. This is a static final attribute. What? Static final attribute. This is a constant. You cannot change it. You cannot say 6. You cannot do that because it is a static final variable. And I know I haven't covered this keyword yet, but it basically means that this is a constant. You cannot change this to anything else. Once this is assigned, this is assigned. It is not changeable. So it already has this math dot pi is equals to 3.14 and so on. It is basically the value of pi stored into it. Okay. So what you can do, if I want to check, if I want to convert, say, pi by, what is pi by 2? I want to check. So I can say math dot 2 degrees. I can say math dot pi by 2, 90. Pi by 2 is 90. Is it correct? Pi by 2 is 90 degrees. Is it correct? Yes. Yes, pi by 2 is 90 degree. It is correct. Okay, good. What about just pi? It should give us 180 degree. Let's again try it out. What about just pi? Yes, it is giving us 180 degree. Let's try out by 3. It is giving us approximately 60 degree. Pi by 3 should give us 60 degree. Yeah. Approximately, yes, 60 degree, which is correct. What about this? Pi by 4. 45 degrees. So it is giving us the exact pi by 4 is 45 degree, correct? Pi by 4 is 45 degree. Okay. What about 270 degree? Will it so 3 into pi by 2, will it work? 3 into pi by 2. Let's try it out. 3 into pi by 2. Yes, it is working as well. 270 degree. So that is how you can convert radians into degrees. Okay, that's how you do it. Okay, cool. Okay, that is it. What about, okay, let me find the angles once. So I should not remove them. So if I say math dot sine, and yes, math has 3 trigonometric functions and more than that as well, but I'm just talking about the basic 3: sine, cos and tan. So math dot sine. Okay, math dot sine. So it finds the sine angle. So if I say math dot pi by 2, it will give me 1. Is it correct? This is in radians. By the way, sine, cos and tan always accept only radians, not degrees. Degrees will not work. Yes, there is a way you can convert degrees into radians, but I'm coming on to that later. But this is the primary way it would work. So math pi by 2 sine would give you 1. What about 3 into pi by 2 minus 1.0. Okay. What about just pi? Okay, this is undefined, right? Just pi is what? Just pi is 180 degree, right? Yeah, 180 degrees. It is anyway undefined. Let's check it out once. Okay, pi by 3. Okay. Pi by 4. Okay. What about just copying these things? Let's copy this thing and let's check how correct these are. And what about just pi? Yeah, right. We just copy this one. Copy. Let's go back. Let's paste over here. Oops, too big. Anyway, I'll just delete it. I'm just taking it for reference. So yeah, let's see now. Let's see now. So what I was checking, pi by 2. Pi by 2 is this one. Pi by 2. Pi by 2 sine. Sine I was checking. Pi by 2 sine should give me 1. So pi by 2 sine is giving me 1. This is correct. Okay. What about 3 pi by 2, which is this one? That sine should give me -1. Should give me -1. So is it? Yes, it is giving -1 as well. What about just pi? Just pi means 180 degree, right? Yeah, just pi. Just pi. It should give me 0. It should give me 0. Okay. This seems to be a little bit glitchy. But anyway, this is giving me undefined actually over here. Anyway, what about pi by 3? What about pi by 3 over here? Pi by 3 should give me √3 by 2, which is this. Of course, we are not seeing √3 by 2 over here, but this is √3 by 2. What about pi by 4? Pi by 4 should give us 1 by √2, and this is 1 by √2. You can verify, but yeah, this is 1 by √2 as well. So we're getting it. So you might ask, this is all cumbersome to remember. Pi by 6, pi by 4, pi by 3. Is there a better way? I mean, what if I can just say sine 45 degree? What about if I just say 30 degree? Well, see, here's the problem. The problem is this. Let me quickly show you the problem. Sine, cos, and tan. The problem with them is that they will only accepts radians. Okay, only accept radians, not degrees. Okay, so yes, you can do pi by you can do pi by 2. If you do this pi by 2, you can say sine math dot pi by 2, and you should get, what was the value? You should get 1. You should get 1. But if you try to do something like this, say math dot sine, and you try to do 90, say for example 90, this is wrong. This is wrong. Why? Because it will think that 90 is radian, because it only accepts radians, not degrees. It does not accept degrees directly. So if you give it sine 90, it will think that 90 is a radian, not degree. If you want to do something like this, that yes, I want to give it 90 degree, you have to convert that degree into radian. So while this will not work, but this will work. Math dot sine, and now you will write math dot to radian. So you are converting the degree to radian. You should directly give it 90. It will give you wrong result because it will think it is a radian. So you have to first convert the degree into radian, because it will only accept radian only. So now when you do this, it will give you a required value. Okay, let's check it out, and then we end our video. This is the last topic. Okay, first of all, let me show you what I mean. So math dot pi by 2, this is what you get. Okay, if I try to, this is the radian. If I try to convert this radian into degree, what would I get? Say math dot to degree. to degrees, and I do the same thing, math dot pi by 2. What would I get? I should get 90 degree. I'm getting 90 degree. Perfect. So now the thing is that if I try to find the sine of this, I can either do math dot pi by 2 and I would get it, which is 1. But I cannot do this. This will give me a wrong result. Why? Because this will think that 90 is a radian. But this is wrong result because it only accepts radian. So just like here, to see what is the degree of it, I had to convert it to degrees. Similarly here, to see how much radian it is, I have to convert it into radians. So basically, if I say math dot sine math dot 2 radians and then I say 90, now I'll get 1. Now I'll get 1. Okay. So I can prove it to you. I can prove it to you. Let's do this. Math dot 2 radians 90. Okay, this is a number, right? This is a number. And if I say math dot pi by 2, do you see they are the same number? They are the same number. Okay. So here's the thing. You cannot directly write degrees within it. You have to convert if you want to see what, because sine cos tan only accepts radians. You have to convert the degrees to radians. You cannot directly write the number because it will think, hey, it's just a radian, which is wrong, right? You have to convert the degree into radian. That's how it would work. And as you can see, I'm giving you proofs that yes, if I convert 90 degree to radians, I'm getting this, which is equivalent to math dot pi by 2. And this, like if you go by the trigonometry table as well, so pi by 2, this is in radians, and the same thing is in degree. So this is like to and fro conversion, right? To and fro conversion. Like if I want to go from pi by 2 to 90, I'm going to use 2 degrees. If I am going to from 90 to pi by 2, I'm going to use 2 radians. So basically, if I want to say, what I'm saying is, just to clarify once, in degrees 90 degree, in radians pi by 2. Okay, simple. So if you want to go from here to here, you would say 2 radians. So you are going from degrees to radians, and you would get this. And if you want to go from here to here, you would say 2 degrees and pi by 2, and you would get this 90. Simple, easy to understand, no worries. Again, try doing this on your own once quickly. If I want to go from math dot 2 degrees, math dot 2 degrees, math dot pi by 2, how many degrees? 90 degree. Cool. And if I want to go from 90 degree back to pi by 2, math dot 2 radians, so I'm converting the degree into radians, I get pi by 2. This is pi by 2 only. Okay, so to and fro conversion, right? Easy. And we have these methods. We have sine, cos and tan. All of them accepts only radians. So whenever someone says that find sine 30 degree, this is important. Look at this symbol. If you see something like this, how you're going to write? You're going to say math dot sine. Now I'm going to say math dot it does not accept degrees. So convert this 30 degree into radian. Mat dot 2 radians 30 and then close the bracket. You will get your answer. This should give you 1 by 2, which is 0.5 something, right? Yeah, correct. So that's how this works, and this is how exactly cos and tan works also. By the way, what about the other things? I mean, there are 3 more things, right? What about, see, for example, what I'm trying to say is this. Let me just side count this over here. See, this is in math library, this is in math library, this doesn't matter. What about these? They are not included in math library. They are not there. So how can you find these? Simple. Cot is the reciprocal of tan. Cosec is the reciprocal of cos. Sine. And yeah, right. Oh, am I wrong? It's been a while. I haven't touched trigonometry, but the point is that you can just reciprocal them and you will get your answer, right? So that's how it is done. For example, if I try to find cot, say I want to find cot 45 degree, how would I do that? Cot 45 degree should be 1, right? Let's try find this. Yeah, so I can say basically finding cot 45 degree. Okay, how would I do this? I would simply say tan 45 degree, math dot tan 45. Again, this is a mistake. Do not do this. It accepts only radians, so you have to first convert the degree into radians. Math dot 2 radians 45 degree. This is giving you tan, okay, which is 0.9999. Anyway, it is going to give you 1, right? Let me round this off. Math dot round. It is giving you 1, right? Perfect. So if I want the reciprocal of it, I would simply say 1 by this. This is cot. Simple. This is cot. That's it. Got it? Okay. What if you want to find cosec? What if you want to find cosec? Yep. This one over here. So cosec is the reciprocal of sine. Now I remembered. Yeah, perfect. Cosec is the reciprocal of sine. So say for example you want to find this. What is this? This is 30 degree, right? 30 degree. So you want to find cosec 30 degree. How would you do that? Cosec 30 degree. So first you have to find sine of 30 degree and reciprocal it. So you would do this. If I want to find this, finding cosec 30 degree, I would do something like this. I would say 1 by you are doing reciprocal of math dot sine. Now it's say math dot 2 radians, again converting the degrees to radians. It will not work without this. Radians 30, and you are getting approximately 2 if you just try to round it out. I mean, just round it out. Math dot round, you would get 2. So that's all. That's how you work around trigonometric functions and all these things. So yeah, we are done with math library. I have gone through all the important ones, but if you really want to check it out, go to the Java page or search the internet and you will get all the details about all the other functions over there. So that's all for this video. See you in the next lecture. Bye bye.